Okay, so now let's move on to our next session of the day. I would like to welcome our second speaker of the second day of FTP, that is our Mr. Anjan Ghosh. He completed his undergraduate in physics from the University of Kolkata and later joined the field of computer science and completed his post-graduation in the field of computer applications. He joined TCS in November 2005 and also became a core member of the project of Indian Railways. He has 19 years of IT experience and has come across different domains, starting from human resource, payroll, finance, HIT, and data privacy, being associated with various organizations such as Excellent Technologies and Quest Global. Now he became a technical architect. His specializations include database technologies and programming languages, problem solving and growing expertise in the end-to-end implementation of numerous projects, which includes all the phases of SDLC, starting with requirement gathering, analysis, design, coding, development, testing, customization, and warranty support. According to his notion, acquiring skill sets in AI and ML makes no difference. So that's the introduction for Mr. Anjan Ghosh, sir. Sir, now I would request you to please continue with today's next session.
The conveners, the principals, the head of the department, especially Mr. Shubir, who is happened to be my friends in my master when I was completing my masters, and eventually it was found that it's a very it's a very interesting fact about me and Mr. Shubir. So he is eventually my friend, and that our date of birth is same. And it is discovered at the days when we are at the college, and we was there in some doing some masters in the computer applications. So, and the same day we discovered that one of our another friends is also the date of birth is same. So it's a very amazing fact that all the three members are together and their friends and their date of birth are same, and it is discovered in the same day. So it's a very interesting fact. So what I want to express to all of you. So thanks for thanks, madam, for your brief introductions. It's my privilege. I feel privileged to be here as a guest speaker. So as I am from some business organizations, TCS. So I'm not the academician. So I will not go into the deep into the algorithmic parts of the technical jargons of this AI and ML. I will rather go into the broader perspective of the AI and ML, how it affects our societies, how the interdisciplinary subjects like AI to other fields, from other fields to AI, how they are interrelated, and which is eventually the main topics of this FDP program. So I will start now. So before that, I will present one keynote. I hope my presentation is visible.
Yes, sir, the screen is visible.
Yeah.
Sir, can you please do it full screen?
1 minute. Is it visible now in full screen?
Yes, sir, the screen is visible.
Yeah, so everybody is about to see my screen.
Yes, sir.
Yeah. Okay. Now we'll start. Actually, AI is the buzzword. So, why is a buzzword now? So I'll explain how is becomes so much sensations in the current era of industrial revolution. So, as the name suggests, this is a buzzword. So, artificial intelligence is undoubtedly the hottest buzzword today, and for all the good reasons. I will never say that is for a debate is there. Is a good effect of the AI, is a adverse effect of AI, but I will not go into this debate. But what I can see as my perspective, that for all the good reasons is a buzzword today. In our past decade, we witnessed several techniques and practices so that have previously been a part of science fiction only, and that eventually slowly transform into reality with this onset of the AI. And that AI truly become a factor of productions with the potential to introduce new sources of growth and change the way work is done across industries. There is an interesting facts that some stats are there. One of the leading auditing organizations in the world, the PwC, predicts that the artificial intelligence could potentially contribute nearly about $15.7 trillion to the global economy by the end of the year 2035. And China and the United States of America are primed to benefit the most from the coming AI boom. And also India as our country, they are also not far behind. They are also following the China and the United States, and they will soon become a leading factor because of this human brain and the technologies that India is providing to the world. And that AI impacting is nearly 70% of the global economy. So it's a huge revolutions in the field of IT industries. So everyone is talking about AI, but in some way or some other way, we are already using AI. Maybe we are aware of that we are using AI. Maybe we are not aware of that we are not using AI. But we are using AI in some other way every day in our daily life. So that is how the AI become the sensations in the current industrial revolution. Right, just now, just like this agricultural revolution, this green revolutions, it is going to become the revolution in the IT industries in the year to come. Then, now I'll go to the broader definition of the artificial intelligence. Although everyone is all the scholars sitting here as a speaker, all the eminent speakers and all the learned doctors, all these my fellow speakers, they are all aware of this fact, aware of these definitions. I will not go into the deep definitions of the artificial intelligence. But what artificial intelligence is doing, it is actually mimicking the human minds and the human actions. So what are the human minds can do? What is the cognitive abilities of the human minds? There is a couple of factors: learning, reasoning, and then problem solving, then perception, which is discussed in our yesterday's evening by Mr. Anirban sir, and it's rightly it's a wonderfully explanations of this, how the perception they are creating. and they are infusing into the AI. And the language comprehension, how the machine can understand, how the human can understand the language comprehension, in the same way how we are trying to make the machine understand the language, human language, whatever language we are speaking, maybe Hindi, Sanskrit, English, all this. So all these are the cognitive abilities of the human mind, and that all these cognitive abilities we are going to mimic in the machines. So that is what is the essence of this, what exactly the essence of the artificial intelligence. So in broader perspective, what is the definitions of artificial intelligence? So artificial intelligence is the simulation of human intelligence inside machines that are programmed to think and act like a human, just like we have feelings, we have apathy, we have consciousness, we all these characters. In the same way, we are trying to infuse inside the machines so that the machines can act like a human. So all these cognitive abilities we are trying to boost into the machines. What are those cognitive abilities? This learning, that reasoning, that problem solving, that perception, and this long language comprehension, how they understand the language. So these are all the example of the cognitive abilities. So artificial intelligence is a method of making a computer controlled robot or a software which can think intelligently like the human mind. So AI is accomplished by studying the patterns of the human brain and by analyzing the cognitive process, because the same process the machine is also trying to do. So the outcomes of these studies develops actual intelligence inside the machines, and that is actually what AI is: intelligent software and the intelligent systems driven by the huge ocean of data. Then in broadly, AI is categorized into two different aspects of the AI. The first aspect is how much it is capable. So in terms of capability, the AI is categorized into broadly two ways, even in the three ways also. That is a narrow AI, as a weak AI, and is a general AI, which is also called a strong AI. And the next step of it is a super AI, which is supercomputer. So if I explain a little bit about this strong AI, general AI, by giving some examples. So as the name suggests, so when discussing the artificial intelligence, it is common to distinguish between two broad categories. One is weak AI and one is strong AI. So let's have some definitions of this. What is weak AI and what is strong AI? Weak AI, which is happened to call as a narrow AI also. So weak AI refers to the AI systems that are designed to perform specific tasks. I repeat, specific tasks, and are limited to those tasks only. So these AI systems excel at their designated function, but they lack general intelligence. So examples of weak AI includes a couple of examples I'm going to give you, like voice assistants. So everyone is now or then or they are using the term this Alexa, switch off the lights. So all this command, this voice command is read by these machines, and by the using the IoT, Internet of Things, they are doing some specific tasks. If they are asked to do some intelligent tasks, they may or may not be able to do it because it's a weak AI, it's a narrow AI, because it's a limited to some boundary. So another example is Siri. Siri is a product of Apple. Alexa is a product of Amazon. Like this, a Google Assistant is there. So all these voice assistant software like Siri, Alexa, the Google Assistant, the recommendation algorithms and image recognition systems. Those are known as those examples are the weak AI. So weak AI operates within predefined boundaries and cannot generalize beyond the specialized domain. So that is why it is called weak AI. Another category is the strong AI. That is also happened to known as a general AI. So what is strong AI and the general AI? So strong AI is also known as general AI. So refers to the AI system that possesses the human level intelligence which the weak AI is lacking of, or even surpass the human intelligence across a wide range of tasks. So the difference is the weak AI is a limited task, but in the strong AI, they can they can uh, they can accomplish a wide range of tasks. So that is why the strong AI would be capable of understanding. They have the capabilities of understanding. They have the capabilities of reasoning, learning, and then apply that knowledge to solve some complex problem in a manner similar to how the human cognition. So all these cognitive abilities is being transferred to the machines and they become strong AI. So however, the development of strong AI is still largely theoretical and has not been achieved to date, because all this human capability is not easy to infuse inside the machines. So all the experiments, all the researchers, all the research scholars are doing all these things day and night to have all these human cognitive abilities inside the machines. So they are trying to make a strong AI, general AI. And all this strong AI, when comes together, they become the super AI. So this is the categories based upon the capabilities. Now, based upon the functionalities, what kind of functionality it is doing? So I will give one example. So while I am explaining the types of artificial intelligence, it's a purely reactive. Suppose in a chess game, the machines observes the moves and makes that best possible decision to win. So that is a reactive things the machines are doing. So these machines do not have any memory or data to work with, but they're specialized in just one field of work, like a game of chess. So what they do, they observe the moves, and by applying some logic, they try to make a best possible decisions to win. So that is a purely reactive type of artificial intelligence. Then the limited memory intelligence. What is that? So these machines collect previous data. So they collect some data and continue adding to their memories. So every time the data is coming and they are keep on adding into their memories. So they have enough memory or experience to make proper decisions. But in that case, limited memory cases, they have some limited memory, the minimal memory, which is required. So for example, suppose a restaurant based on the location data that has been gathered. So a machine can suggest, so they are gathering all the restaurants across cities and across the states, across some geographical areas, and they are gathering those informations into their memory. And this is very limited memory, and they are gathering the location of these restaurants. And when there is a query based on your locations, they're finding out the restaurant from you. So that is the artificial intelligence, but it's a limited memory intelligence. Next kind of artificial intelligence is a theory of mind. So as a human beings, we have emotions, we have empathy, we have apathy, we have consciousness. Okay. So those kind of human cognitive abilities, they're trying to mimic. So this kind of AI can understand our thoughts and emotions, and as well as they can interact socially. So in Odisha, some of the news channel has created one bot, and they're just like a woman, the anchor, and they just reading the news, looking into the first sites. You'll not be able to understand that it's a real or it's a artificial. So they have some emotions, they have some thoughts, so they have some empathy, they have some consciousness. So these are all the theory of our minds. So this kind of AI can understand thoughts and emotions as well as interact socially. They can interact socially. So however, a machine based on this type is yet to be built, but it is going to be near future of AI. Then next kind of is the self-awareness. Is one step ahead of all these human minds cognitive abilities. So self-aware machines are the future generation of these new technologies. They'll be intelligent, they'll be sentient, and they'll be conscious. So all these human behaviors are going to be mimicked into a machines. So this kind of AI is called the self-aware AI. So these are broadly categories of AI. So one category is based on the capabilities and one category is based on the functionalities. So this is the types of AI. Now, so now comes to the implementation part of the AI. How the artificial intelligence can be implemented. So artificial intelligence is a discipline. It's not a individual subjects. It's a vast oceans, artificial intelligence. So when you tell artificial intelligence, it is supported by some group of algorithms, some reasoning, some learning experience, some data. So all this together make artificial intelligence. So main part of this artificial intelligence is the machine learning. And one step go forward, it is a deep learning. So there is a difference between what is machine learning, what is deep learning. So machine learning. What is machine learning? So machine learning focuses on the development of the algorithms and the models that enable computers to learn from data. So data is the factor here, and make prediction or decisions without explicit programming. So what is that? So there is some characteristics of machine learning. What all those characteristics, which comprises the entire subjects, is a machine learning. First of all, is a feature engineering. So what is feature engineering? In machine learning, experts manually engineer or select expert like us or the who are the practitioners of the artificial intelligence. So they manually engineer or select relevant features from the input data they are gathering as part of this machine learning when they are training the data. So they are gathering some relevant features from the input data and aiding to the algorithm in making the accurate predictions. So that is called feature engineering. Then next step is a supervised and unsupervised learning. So what is supervised and unsupervised learning? So machine learning algorithms can be categorized into supervised learning, where model learns from labeled data with known outcomes. So the outcomes is already known, and the data we are receiving, they are the labeled data. Whereas unsupervised learning, they are unlabeled data. So bringing out the features from this unlabeled data is a tough. So that is what the unsupervised learning is doing. So the algorithm, they are the robust algorithm, robust enough, so they are discovering the patterns out of it. We are not infusing some features into this data. The features is already there inside the data, but as it's unlabeled data, so that features is been discovered by the algorithm itself. So they are discovering the patterns and they are discovering the structures in the unlabeled data. So that is unsupervised learning. So machine learning is comprised of feature engineering, supervised learning, unsupervised learning. And then comes the broad applicability. What is broad applicability? Machine learning techniques find application across various domains, including image and speech recognitions.
Sir, can you please wait a second? Miss Atri Datta ma'am, can you please off your mic? Some disturbance is coming from your side. Atri Datta ma'am, can you please turn off your mic? Sir, am I audible? Sir, I have muted all the participants, but you have to turn on your mic from your side.
Yeah, can you hear me now?
Yes, sir. Now you are audible. Thank you, sir.
Yeah, okay. Thanks for all your patience. So what I was talking about, the broad applicability of the machine learning. So machine learning techniques find application across various domains like image recognitions, speech recognitions, natural language processing, and recommendation systems. So these are the broad applicability of the machine learning. Now I go into the deep learning. What is deep learning? As the diagram suggests, so deep learning in encapsulated within a machine learning. So deep learning is a subset of machine learning. So all the machine learning features are already there, On top of that, we are putting some deep learning mechanism. So what is that deep learning? Actually, deep learning is a subset of machine learning that focuses on training artificial neural networks, where we get that inspiration. We get that inspiration from our human brain structure, how they structures. They are structured as layers. And all these layers are interconnected by neurons. So this human brain structure, how they function. So these are the deep learning. So we are mimicking the human brain structure to create algorithms. So as machine learning have some feature extraction, features engineering process, but in the deep learning algorithms have the ability to automatically extract the relevant features from the raw data. No features is being imposed in the data, and that is the unlabeled data, and that features is extracted by applying some algorithms, and it should be a relevant features, and it has the ability to automatically extract that features from the raw data. So that eliminates actually the use of the feature engineering, because we don't have to explicitly do the feature engineering for this data. So it is eliminating the need for explicit feature engineering. So that is called the automatic feature extractions. So by using this algorithm. Then deep neural networks. So deep neural networks. So deep learning employs neural networks with multiple layers of interconnected nodes. That means all these nodes is called neurons. And that enable the learning of complex hierarchical representation of data. Because that is how the learning model is. They are just like a layers of interconnected multiple layers, and those layers are connected by using some nodes, and those nodes are called neurons. Just like inside our memory brain, there are millions of neurons. So in the same way, this deep neural network is working. And another features of this deep learning is high performance. So deep learning has demonstrated exceptional performance in domains such as, suppose, computer vision, natural language processing, speech recognitions. I'm giving some speech, they are recognizing, and they are translating it, and they are making a text out of it. So that is a speech recognition. They recognize my speech, and that example of that is Alexa is also one example of that. They are recognizing my speech. And the natural language processing, we are typing something, by using these words or the jumbling of words, they are finding the correct, they're recommending the correct, just like Google search is doing. So that is the natural language processing. And that often surpasses the traditional machine learning approach. So this is the deep learning. Now I will go to how the artificial so how we are implementing the deep learning in AI. So how does artificial intelligence work actually? So AI systems works by merging large amount of data with intelligence and iterative processing algorithms. Every time when we are training the data, we are doing same things again and again. So this combination allows AI to learn from the patterns and features in the analyzed data. So each time the artificial intelligence system performs a round of data processing, they are getting the data continuously and they are processing the data. So when they are doing this round of data processing, it tests and measures its performance and uses these results to develop additional expertise. So that is how the artificial intelligence is working. That is the working structure of the artificial intelligence. Now, how we are implementing the artificial intelligence in various discipline. So as machine learning that gives AI the ability to learn, so this is done by using some algorithms to discover patterns, and out of this pattern, they are generating some insights from the data which is exposed to them. Whereas in the deep learning, which is the subcategory of the machine learning, it provides AI with the ability to mimic a human brain's neural network. It can make sense of patterns, noise, and sources of confusion in the data. So how does it work, this deep learning? So there is a layers of neural network. That is input layer. There's a couple of layers. So they are categorized as input layer, hidden layer, and output layer. So I have one examples. There is a image of a cat. So what it is doing? At first, it is decomposing these images into some pixels. And each pixel is going to those nodes. And these nodes, these inputs nodes, is having some features. So each dotted line connected with this input layer is passing some features to the neurons. So that is the first layer of the model. So that is input layer. In between, there is a hidden layers. And the last, there's an output layer. So output layer is giving, so there is some mathematical calculations, how they are calculating these weights. There is some weights and they are multiplying, then they are summing up this multiplication results, and they are doing some calculation, and they are they are calculating the confidence, how much it is tend to be a bird, how much it is tend to be a cat, how much it is tend to be a dog. So out of all these calculations, they are finding that this is cat is the maximum probability. So this from this one means image, this digital image, they are extracting the they are decomposing into the pixels. They are sending the pixels as a features. Each pixel has a features to this neural network, and they are at last they are finding this is a image recognition. How they are recognizing the image, so that they recognize as a cat. So this is how the deep learning, the neural network is working. So as I already told, that the images that we want to segregate go into the input layer first, and then so arrows which is drawn from the image to the individual dots, these circles, is the input layer. Each of the circles in the violet layer, the first layer, are a pixel in the picture. So these images fill the violet circles in the input layers. Then comes the hidden layer. In the hidden layers, They're responsible for all the mathematical computations that I already told, and our feature extension or our inputs. They are extracting the features from the inputs. So in the above image, the layers shown in the pink color represents the hidden layers. The lines that are seen between these layers are called weight. Each one of them usually represents a float number, or it can be a decimal number as well. So which is multiplied by the value in the input layer. They are multiplying with this weight, and all these weights add up in the hidden layer. So then the dots, the circles in the hidden layer represents a value based on the sum of the weights. Then these values again pass into the next hidden layer. So you may be asking why there are the multiple layers, because the hidden layer function as an alternative to some degree. So the more the hidden layers are, the more complex the data goes in as an input in the input layer, and what can be produced. So the accuracy of the predicted output generally depends on the number of hidden layers present and the complexity of the data going in. So I have mentioned it as a n. So n numbers of hidden layers can be there based on the complexity of the data. Then next comes the output layer. What is output layer? The output layer gives us the segregated photos. So once the layer adds up, so all these comings from the hidden layers, so they are adding. Once the layers adds up, all these weights being fed, and it will determine if the picture is a cat and is tend to be a dog or she tend to be a bird. So then how this is working in the deep neural network. So that is what about the deep learning is. Now I go to the next slides. So out of all these cognitive features the human possess, learning, reasoning, problem solving, perception, language comprehension, in broadly AI is using the learning process, reasoning process, and the self-correction process. So then I will come to the practical implementation of the cognitive skills, how this logical reasoning, knowledge representation, planning and navigations, natural language processing, perception, emergent intelligence, all this I will give one example. So first I will start with how the learning process. So artificial intelligence emphasizes 3 cognitive skills of the humans. One is learning. Then out of this learning data, they are putting some reasoning, and out of the when they put some reasoning and they are getting some informations, and they are again doing some correction on the data to make it more robust. So that is called self-correction. So that all these skills the human brain already possesses, one degree or another. So we define this in the context of AI is learning. First they are learning. So what they are learning? The acquisition of information and the rules needed to use that information. So that is the learning process. Reasoning process, they're using whatever information they're getting, they're using that information rules to reach definite or approximate conclusions. Means it can be a definite conclusion, it can be an approximate conclusion. Then they are doing some self-correction. So the process of continually fine-tuning. So AI algorithms and ensure that they offer the most accurate results they can. So they're doing learning, they're doing reasoning, and they're doing self-correction, they're getting some accurate results. So these are the steps of cognitive process skills the AI programming is using. Now, so how the artificial intelligence is implemented? So they are doing some logical reasoning. So what they have implemented by using this logical reasoning? So there is an example that in the year 1996, the 10th of February, IBM has manufactures a computer which has expertise in playing the game of chess, and that is called the Deep Blue computer. And one competition session was arranged between this IBM's Deep Blue computer and that time Grandmaster, this Gary Kasparov, the former world champion. So that time in the 1996, he is the former, Gary Kasparov was the former world champion in the chess. So they perform. So these machines, AI programs machines, enabled with AI, the computers has performing some sophisticated tasks. That is, they're applying the logical reasoning. So this is the game of chess. They're playing with the former, and eventually the Gary Kasparov is defeated by this computer. So how much logical reasoning they're applying, so they can defeat the former reigning world champion, the Gary Kasparov. So that is the amount of reasoning power the IBM has manufactured inside these computers. Then knowledge representations. You have heard about some programming language like object-oriented programming, like Smalltalk. So Smalltalk is an object-oriented programming language, dynamically typed. They don't have any syntax or the semantics. They don't have any definite data types, but still they are object-oriented language. So this is a knowledge representation. The Smalltalk is an object-oriented and dynamically typed reflecting programming language that was created to underpin the new world of computing, exemplified by some human-computer symbiosis. Means whatever I am telling, computer can understand. What is computer telling, I can understand. So there is a symbiosis between the human and the computer. So that is one software, that is one object-oriented programming language. So that is the knowledge representations of the artificial intelligence. Then artificial intelligence is implemented in the planning and navigation as well. How? The process of enabling a computer to get from point A to, suppose some vehicles is going from point A to point B. So that is this is the navigations of this car. So one prime example of this is Google self-driving Toyota Prius. So Toyota has invented one car, Prius model, which can drive itself without a driver. So it's a self-driving. So this is the example of artificial intelligence in terms of planning and navigations. Then come the natural language processing. What is natural language processing? Natural language processing, the set of computers that can understand and process the language. So all these semantics, all these grammars, all this is fed into these computers. And whenever someone is writing some text or some words, so they can understand the language. So some data is being fed into the machines, all these semantics, all these grammars, all these words, all these sentences, and they can understand the natural language. So that is called the natural language processing. That is also one kind of artificial intelligence. Then the perception. Yesterday, Mr. Onivan sir was talking about, so they have implanted some chip inside this human brain. So that is perception. So we have our 5 sense organs, right? So human has some sense organs. All these sense organs can sight, can hear, eye can hear, I can sight. By using ear, we can hear. By using our skins, we can touch something. By using our tongue, we can taste something. By using our nose, we can smell something. So these are the perceptions. So we can sight, we have all these biological constructions that is called the 5 sense organs. Okay, so all these sense organs is together inside human. By using this, they are perceptualizing something. So that is called perception. So we are trying, the AI is also trying in this field of perception. They're using some computers to interact with the world. They're trying to make the computer in near future, and it is habitable. So they are trying to create a computer or the robot who can sight, who can hear, who can touch, who can taste and consume. So perception also is a part of artificial intelligence. Then the last one is the emergent intelligence. So some intelligence which is not explicitly programmed into the machines. So intelligence that is not explicitly programmed, but emergence from the rest of the specific AI features. All these AI features, they're coming together and they're creating some intelligence. So the vision for this goal is to have machine who can exhibit. As of now, we cannot find any machine who have emotions. So that emotion also they are trying to put into these machines. So that is called the emotional intelligence. And also some kind of moral reasoning. So that comes under the emergent intelligence. So that is also one kind of AI research. So in near future, we'll be able to find some robots who can show his emotional intelligence. So all this AI-enabled device, they can recognize the speech, they can detect the object. Suppose in this example, this deep learning neural networks, that we can detect the object. So they can do the object detection by using the AI-enabled device. They can solve problems, they can learn from the given data. And they can even plan an approach for future tests to be done. So all these tasks is performed by AI-enabled device. They're already doing it or they are going to do that. Now I will come to the debatable part. The debatable part is how we can understand is it blessings or is a curse? What is the when the science evolution was there? So there are always two branch of peoples who can say who are saying that science is a curse for us. Who are saying no, science also blessings us. So in the same way, AI also bringing two set of peoples. One is they're thinking the AI is going to supercharge the human, and someone is thinking negatively that we are going to lose our job because of this AI. So as the picture suggests, the balance is leaning towards the positive sides. Means AI has pros and cons, there's no doubt. But how you can leverage this AI for the benefit of the human civilizations? So we have to look always positively. There is some measures need to be taken by the government, the institutional organizations, the AI fraternities, the artificial intelligence practitioners, the common peoples. All this together, we can get a better future by using this AI. So, what are the important advantages and what are the disadvantages of AI? So, advantages of so artificial intelligence has its pluses and minuses both. But much like another concept or innovations, there is some pros and cons. What is pros? It can reduce the human error. It will never sleep. So it is a 24/7, means we can get the service of the AI. It's not like means human people that they will tired of doing the jobs and they need some rest hours, at least 8 hours a day or the 9 hours a day. But the this machines never stops. So it's the advantage of the AI. It never sleeps. So it is available 24/7. And also something repetitive work we are doing. So what we'll feel, we'll get bored of it. Sometimes we are doing some repetitive tasks again and again. So we'll getting bored of it. So it never gets bored. So it easily handles repetitive tasks. And the last and not the least is the fastest decisions making technology. This is a fast. Within a seconds, we can get the entire information in our mobiles or in our laptops or in our tabs. So as every science innovation has its pros, they have cons as well. First of all, it's very costly to implement. Why it's cost is needs a huge amount of server to load the data, because the data is the main essence or the feed of this AI to function. Another one is most important. Human has some creativity. So as there is a fear psychosis that human can lose the job, but they will never. Why? Because of these cons. Because it cannot duplicate human creativity. So every person has to be creative. They has to have some innovative ideas. So it cannot duplicate human creativity. And it will definitely replace some jobs, leading to unemployment. But there is some measures as well. So government has to jump into this. Actually, governments, all these organizations, all these institutions, all these academics institutions, all this have to be raise their hand to minimize this effect of this AI. How to do that, I will come later. And people can become over reliant on it. Means everything machine will do, I will do nothing. So nowadays the humans are very fitness fanatic. But AI is telling you that I will do everything for you. You don't have to do anything. So if the people might feel lazy enough, and they will become lazy. And day by day, they will overly reliant on it. So that is one of the cons. So that is also our characters. We can minimize it. That is within our reach. So these are the pros and cons. And then now I come to the actual subjects of this current FDP program. How is the application artificial intelligence can be used in an interdisciplinary domain? So there is a lots of domains. I will not go to all the domains. Couple of domains are automobiles, manufacturing, gaming, government, healthcare, finance, education, business. Okay, I will go one by one. I will cover couple of the applications, how the artificial intelligence is implemented. So artificial intelligence has a wide range of applications across various industries and domains. So some of the notable applications of AI are natural language processing that we already have discussed. So AI is used in NLP, which is called as a natural language processing, to analyze and understand human language. So it powers applications such as speech recognitions, machine translation, sentiment analysis, and virtual assistants like Siri and Alexa. So that comes under natural language processing. So this is one domain we are using the artificial intelligence. And the next domain is image and video analysis. How? So AI techniques, including computer visions, enable the analysis and interpretation of images and videos. So that is how they are analyzing the image and videos. So where it is practically is in use. So this find application in facial recognitions, object detection and tracking, content moderations, medical imaging, and autonomous vehicles. So in US, it is mandatory to put a camera in front of the windshield, not only get some, in case of accident, not only get some insurance amount, but also feed the data to the server to feed the live data. Whenever the car is moving, they are feeding the live data, and they are using this live data to make some predictions. That is, example is Google Map. Then the robotics and automations. So AI plays a crucial role actually in robotics and automation systems. So in the science universities or science technological universities, the robotics is a subjects. So AI can be used inside robotics. So this is an interdisciplinary connection of this AI and the robotics, and automate the entire systems. So robots equipped with the AI algorithms can perform complex tasks. In which area? In manufacturing, in healthcare. Now look at the connections. AI is using inside robotics and automation, and that automation is make their input into the manufacturing, healthcare, logistics, and explorations, science explorations. So they can adapt to changing environments. So learn from experience and collaborate with humans. So here also, humans actually is required to make a robot. So whoever is in fear psychosis that they can lose their job, but they can use those opportunities. Then the recommendation systems. So AI powered recommendation systems are used in e-commerce, suppose streaming platforms, suppose social media, suppose in YouTube, or suppose Amazon or Amazon this shopping media, and this uh, Flipkart. All these are using these recommendation systems. So there is also AI has its presence. So AI-powered recommendation systems are used in e-commerce, streaming platforms, social media, personalizing your experiences. So they analyze user preferences. What suppose you are in the some marketing websites, suppose Amazon. So they are already have they by surfing this Amazon or the Flipkart, you already put the information to them that I am fond of this product, I have personal preference in this product. So they are analyzing their preference, they are analyzing their behavior based on the historical data to suggest some relevant products. So you will amazed of that how which I have searched before and which I needs, it is already sensed by the system and it is already displaying in the marketing websites. Then it is AI has used in the financial services as well. So AI is extensively used in the financial industry for fraud detections, algorithmic trading, credit scoring, risk assessment, machine learning models. So machine learning models can analyze vast amount of financial data to identify patterns and make some predictions. So AI is broadly used in the financial services as well. And again, in AI is used in the healthcare domain as well. So AI applications in healthcare include disease diagnosis. It includes medical imaging analysis, is drug discovery, is personalized medicines, in patients monitoring. So all AI has its presence. So AI can assist is identifying patterns in medical data and provide insights for better diagnosis and treatment. So, so for the interest of time, actually I already passed my stipulated time. So is it okay to continue or I can end, draw some conclusion here? Hello? Hello?
Yes, sir.
So actually, I already passed my stipulated times. 5:30 is over. So is it okay to end here, or I can continue?
Yes, sir. Of course. It
If
is very much
all
okay.
the persons being there in this forum are not getting bored. Okay, then
I may request all the participants, if you have any question, please raise your hand and you can unmute yourself and ask Mr. Anjan Ghosh, sir. If anyone have any question, just raise your hand and ask, sir. I think nobody have any questions, sir, and it is already 5:30. Thank you very much, sir, for your wonderful and knowledgeable session. It's very much industrial based, and it was a wonderful session on AI.
yeah, thanks, ma'am. Thanks everybody to listening to me patientfully. So all I ends with, that's there is a perception is going on, this like man versus machine. There is a famous quote that it's not man versus machine, it's actually it's man with machine versus man without machines. So data and intuition out of it are like horse and the rider. You don't try to outrun a horse, you better ride it. So that is how I can conclude. Don't go by the fear psychosis. Always try to be with the current technologies, and all the learners, educationists, all our researchers can help us and as well as the community, so they can get the maximum advantages of the artificial intelligence. That's what I can say. Thanks for
Of course, sir.
having this wonderful evening.
Thank you, sir. It was our pleasure to have you here.
Yeah, thanks, madam. So I am just answering my document. Okay.